Hello everyone. So welcome to this platform. So today I want to take you through science paper 1 that was written last year. So this is the paper that our students wrote last year. It was written on 7th November 2025. So let's just go through this paper and see what our friends wrote. Okay. So let's just quickly start answering. Okay, so this is the first question. So question 1 reads, the diagram shows an extract from an ammeter in use. Okay, so this is the diagram of an ammeter. An ammeter is an instrument that measures current. Okay, so the question says, what is the reading of the ammeter in amperes? Okay, so what is the reading of the ammeter? So in other words, what they are asking you is, what does the pointer indicate here? What is the value here? Okay? Yeah. So let's read it. So for us to read this ammeter, we first of all need to know how they were moving. Okay? We need to know what is the reading for, what is the value for each unit, one step. So if I move from 0 to 10, how many units for each step? Okay, so from 0 to 10, let's move. So 0 to, let me just try to zoom it. Okay, so this is 0. So 2, 4, 6, 8, 10. Okay, you can see each step represents 2 milliamps. Milliamps. Okay, so what is the reading here? So we are at 10 here. Let's move up to there. So 10, 12, 14, 16. So it means that the reading here is 16 milliamps. But they are saying we should read this in amperes or amps, meaning we shouldn't have the milli. So first of all, we know that the reading there is what? 16 what? Milliamps. We know the reading there is 16 milliamps. Now this reading has to be in amps. We need to find the way to remove the what? The milli. So what I want you to know is that milli, when you hear the word milli, small letter m. So milli represents 10 to the power negative 3. It's a prefix in measurement that represents 10 to the power what? Negative 3. So what we want is amps. We just want to have A there. Okay, so where there is milli, we need to remove this and put 10 to the power negative 3, which is the same as saying we get this value, then we divide by 1000. Because 10 to the power negative 3 is the same as 1 over 10 to the power 3, which is 1 over 1000. So we just divide this value by 1000. So we're going to say 16 divided by 1000. Then we're going to get 0.016. Okay? So we've removed the milli. We now have the what? The amps. Remember, this instrument was in milliamps, but we want the reading to be in amps. So this corresponds to answer choice what? B. So the correct answer here was what? B. Okay, so the answer here was B. Yeah. Okay, so we move on. So we go to the next question. The diagram shows a simple pendulum whose periodic time is 2.5 seconds. Okay, so this is a simple pendulum and the period of the pendulum is 2.5 seconds. Okay, the question says, how long will it take the pendulum bob to move from A to B? So how long will it take the pendulum bob to move from this point A to point B? So what we know is that the period of the pendulum here is 2.5 seconds, okay? So period of the pendulum is simply the time taken for the pendulum to make one complete oscillation, okay? So the time it takes to make one complete oscillation. By complete oscillation, I mean this to and fro movement of the bob. It means the movement from A to C and back to A. That is one complete oscillation. And the time it takes to make that complete oscillation is what we are calling what? Period of the pendulum. So we use the symbol capital letter T to represent period. So we know the period here is stop 2.5 what? Seconds. So we know that it took 2.5 seconds to move from A to C and back to A like that. Now the question is, how long will it take to move from A to B? Okay? So what I want you to know is that we are saying A to C and back to A is one complete oscillation, meaning just A to C, this is half oscillation. In fact, from A to B, it's a quarter, B to C, another quarter, just like that, okay? So what I'm saying here is that A to B, this is 1/4 oscillation. B to C is another 1/4. C to B, another 1/4. And B to A, another 1/4. That is what you want to know here. So you can see that from A to B, 1/4. B to C, 1/4. 1/4 plus 1/4 is 1/2 or 2/4. That is why I'm saying from A to C, it's half oscillation. Then if you add 1/2 plus 1/4, you get 3/4, 3/4. 3/4 plus 1/4, you get 4/4, which is 1. That is why we are saying from A to C and back to A is 1 oscillation. So what we want to know is the time it takes only to move from A to B. So you should also be familiar with this formula. So period of the pendulum, capital letter T, is equal to the time taken divided by the number of oscillations. So period of the pendulum is equal to the time it takes divided by the number of oscillations. So here we can just use this formula and find the value. So we know that the period of the pendulum is 2.5. So this equals the time taken is what we're looking for, small letter t, divided by how many oscillations? We are looking at the time it takes to move from A to B. So the number of oscillations just from A to B is 1/4. In fact, 1/4, you should know that 1/4 is the same as 0.25, okay? 0.25. So here I will not put 1/4. Let me just put 0.25 so that I can easily find the value here. So yeah. Then what we do, remember this is a fraction. It's like 2.5 is equal to t over 0.25. So this is also over 1. So you're going to cross multiply. So 0.25 multiplied by 2.5 will give you the value of t. So t is equal to, so when you multiply those, you shall get 0.625 seconds. So it takes 0.625 seconds. So what is the best answer here? Okay, so let's round off this to two decimal places. Okay, so if I round off this to 2 decimal places, I'll add 1 to 2 here. It will be 0.63. So 0.63 seconds. Okay, so that is the time it takes. So that is the answer. So the answer here was B. Yeah. Others would have said, because we know the time it takes for one complete oscillation. So you can say for one oscillation, it takes 2.5 seconds. That is for one oscillation. How about for 1/4 oscillations or for 0.25 oscillations? How long will it take? Let me just say small letter t here. Then you can find the value of what? T. You see that you just need to cross multiply. This times that is t, then this times that will give you, okay, this is supposed to be 0.25 here. Yeah. So you still get the same answer. Okay. Question 3. A car travels between towns which are 96 kilometers apart in 1.2 hours. What is the average speed in meters per second? So average speed will be equal to total distance divided by total time taken. So average speed will be equal to total distance covered over total time taken. So the total distance covered was what? 96 kilometers. Time taken was the 1.2 hours, but we need to find the speed in meters per second. So you need to convert this kilometer to meters, okay? So what I know, and what you should also know, is that 1 kilometer is 1,000 meters. In fact, the word kilo, this one kilo, small letter k, means 1,000 or 10 to the power 3. It's also a prefix, which means 10 to the power 3 or 1,000. That is why 1 kilometer is 1,000 meters. Meaning, 96 kilometers. So 96 kilometers, we need to multiply by 1000. It will give us what? 96,000 what? Meters. So we have converted what? Kilometers to what? To meters. The next is to convert hours to what? Seconds. So let's convert these hours to seconds. So what you should know is that 1 hour, I know you know that 1 hour is 60 minutes. But you should also know that 1 minute is equal to 60 seconds. So 1 hour is equal to 60 times 60 seconds. Or in other words, 1 hour is equal to 3,600 what? Seconds. 1 hour. So for every hour, you have this number of seconds. How about 1.2 hours? So how about 1.2 hours? So 1.2 hours. So you can use your calculator here. Let me just grab my calculator. Okay. Yeah, so 1.2 hours, so you cross multiply there. So you cross multiply, it means 1.2. So it means 1.2 times this one, 3,600. So 3,600 times 1.2, it's giving me 4320. So 4320 seconds. Okay. So we now have the time in what? In seconds, and the distance in what? Meters. So we can now come back to this formula and find the speed in meters per second. So our speed will be equal to, the distance is 96,000 meters divided by the time taken is 4320 seconds. Okay. Then what is the answer? So you divide now. So you use your calculator. Sorry. So I'm so sorry. So sorry. This has to be small letter M. This has to be small letter S. Okay. There we have it. So 96,000 divided by 4320. Okay, so I'm getting 22.22222 like that. Okay, yeah, which we can just round off maybe to 2 decimal places and say this is the same as 22.22 meters per second, like that. Okay, so this corresponds to answer choice what? B. So the best answer here was B. Okay, so let's move on to question 4. Question 4 says, the diagrams show two forces acting on mass M in the direction shown. Which of the diagrams show the arrangement of forces that give the block of mass M the greatest acceleration? So we have two forces that are acting on their mass. Now, which combination of the two forces will give us the greatest acceleration? So because they are mentioning about acceleration and the force, this is testing us on something called Newton's second law of motion. So Newton's what? Second law of motion. That is what it is testing us. Now, what does this law state? So Newton's second law of motion states that the acceleration A of a body or an object is directly proportional to the net force acting on that body, but inversely proportional to the mass of the body. So acceleration, small letter a, is equal to the net force divided by what? The mass. So you can see that acceleration is proportional to the force, net force, but inversely proportional to the mass of the body. What we mean here is that every time we increase the force, the net force, we are going to increase the acceleration. If we reduce the force, we reduce the acceleration. But if we increase the mass, we're going to reduce the acceleration. That is what we mean. So what we just need to do here, we just want to figure out which combination of two forces will give us the greatest what? Net force. Which one will give us the largest net force? We don't need to worry about the masses here because the masses are the same. So we just need to know which one has the greatest net force. The one with the greatest net force will give us the greatest acceleration. So the first, what we're going to do is we need to find the net force in each case. Then we just see which one has the largest value. So let's find the net force in each case here. So here we can see we have two forces that are acting on the body and they are moving in the same direction. So if two forces are moving in the same direction like that, they are collinear, they are moving in the same direction, okay? What I want you to know is that you want to add the two forces because they will have the same effect on the body. So the net force here is what? 10 plus 12, which is 22 newtons. So that is the net force and it goes to the right. But we don't want to worry about the direction here. We just want to know the size. Okay. How about this one? What is the net force? So here, there's this force that goes to the right, then this force goes to the left. Because they are moving in opposite direction, you want to subtract the two forces to find the net force. So you shall say 12 minus 10. So this will give you what? 2 newtons. Okay. And it goes to the left, okay? It goes to the left. We know it goes to the left because that's where the larger force is directed to. How about this? This force goes to the left, it pulls in that direction, this one pulls in that direction. They are moving in opposite directions, so we need to subtract. So we are going to say 30 minus 20, and this will give us what? 10 newtons. And it goes to the right. How about this one? These two forces are pushing the object. This one is pushing that direction, and this one is also pulling that direction. They are going in the same direction, okay? Yeah, so we're going to add to find the net force. So we shall say 20 plus 30, which is 50 newtons. Yeah. So you can see that D gives us the greatest what? Net force. So it should be D that will give us the what? The greatest acceleration. So if the question was which one gives us the least acceleration, you would pick this one with the least net force. Okay, yeah. So the best answer here for the greatest acceleration is D. Okay. So let's go to this question. This will be our last question of this video. Yeah, then I'll also create other videos now. I'll start from question 6 until we finish this paper. I'll be making videos. So you just need to subscribe to our channel so that you don't miss our videos, okay? Yeah. Apart from that, you should remember to register for tuitions with us so that we can help you pass your exams. If you're writing your GCE, you're in grade 12, you're in grade 11, we can help you pass your exams, mathematics, science, social sciences, and other subjects that you'd want us to help you with. Okay, so let's start question 5. Let's do question 5. So question 5 says, the diagram shows a trailer being pulled by a car on a frictionless horizontal surface by applying a force of 1000 newtons. So this is a trailer that is being pulled by the car, and the pulling force here is 1000 newtons. The trailer covers a distance of 300 meters in 60 seconds. What is the power exerted by the car on the trailer? Okay. So what I want you to know is that power is the rate at which work is done. So power is equal to the work done divided by the time taken. Okay? So power is simply the rate of doing work. So it's equal to the work that you do divided by the time you take to do the work. Yeah. So to find the power here, we first of all need to find the work done by this force. So work is done when a force acts on an object and it moves it in the direction of the force. So work done is simply the product of the force, okay, and the distance moved in the direction of the force. That is what we mean by what? Work. So the product of the force and the distance moved in the direction of the force. So in this case, the force is 1000 newtons multiplied by the distance covered is 300 meters. So this one will give us 300 what? 1000. So 300,000 what? Joules of work was done. So 300,000 joules of work was done by the car on the trailer. Now what is the power? So we shall say power now is equal to the work done is 300,000. We need to divide this now by the time it takes, 60 seconds. Okay? Yeah. So it means that you can use your calculator here, or if you want, you can say This 0 and that 0 cancel, then 6 there, 1. 6 into 30, that is 5. So we shall have 5,000 there. If you want, you can use your calculator. So this will give us 5,000 watts. Okay? Yeah. That is how you calculate the power. So this corresponds to answer choice what? A. So this is the best answer. So there you have it. That is how you'd have answered question 1 to 5 in this paper. Okay. Bye-bye.